Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper for exam for IGCSE Physics, October-November 2023, variant 1. So let's get started. Question 1 says a girl holds a rubber ball out of a window of a tall building. The mass of the ball is 0.20 kilograms. The ball is at rest 10 meters above the concrete path. Calculate the gravitational potential energy of the ball relative to the concrete path. So we use mgh. So we have the mass and gravitational acceleration is known and the height above the ground is known. So 0.20 in kilograms already times 9.8 times the height 10. This gives an answer of 19.6, or we can approximate it to two significant figures to 20, and the unit is joules. Question B says the girl releases the ball and it falls towards the path. The ball strikes the path and bounces vertically upwards. Figure 1.1 shows the ball falling towards the path. The speed of the ball immediately before it strikes the path is 14 meters per second, and after it strikes the path is 12 meters per second. That's upwards, so it changed direction. Calculate the kinetic energy of the ball immediately after it strikes the concrete path. So we use kinetic energy equals half mv squared. So that's half times 0.20 times the speed after it bounces, that's 12 squared. This gives an answer of 14.4, or we can approximate it to 14 joules. Part I says show that the change in momentum of the ball when it bounces off the path is 5.2 kilograms meters per second. So the change in momentum or the impulse is equal to the mass multiplied by the change in velocity, or mass times final velocity minus mass times initial velocity. So that's 0.20 times 12 minus negative 14. Since there was a change in direction, we choose one direction to be positive and the other to be negative. In this case, I chose upwards to be positive and the original downwards direction to be negative. This gives an answer of 5.2. Part I says the ball is in contact with the path for 0.25 seconds. Calculate the average resultant force on the ball when it is in contact with the path. So we use force equals to the change in momentum over time. Of course, you can use force equals mass times acceleration, but then you are required to calculate the acceleration first, which would take a longer time. But here we already have the change in momentum. Even if you did not know how to show that it's 5.2, it's given as 5.2, so you can use it. And then divide by the time, 0.25 seconds. That gives an answer of 20.8 Newton, or you can approximate it to 21 Newtons. Both are correct, since the whole question has its own numbers in two significant figures, so you can use two significant figures or one more significant figure. Question 2 says a copper cooking pan contains water. Figure 2.1 shows the pan on a hot plate of a cooker. Copper is a metal. Question A says thermal energy is conducted through all solids by lattice vibrations. Describe one other way in which thermal energy is conducted through the copper. So you can say that as the molecules with higher energy collide with the adjacent or neighboring molecules, the free electrons gain enough energy to move from molecule to molecule or from atom to atom, transferring energy. Question B says the outside surface of the cooking pan is kept clean by regularly polishing. Explain one other advantage of keeping the surface of the pan shiny. So we say that shiny surfaces are poor emitters of infrared radiation, so there will be less heat lost to the surroundings. Since you're not emitting heat to the surroundings, the energy is kept inside and you use that energy to cook the food. Question C says the thermal energy passes into the water through the base of the pan. Identify the main method by which thermal energy is transferred through the water, which is a liquid. So the main heat transfer method for liquids or gases, that's convection. This is the fastest way through liquids and gases. Question 3 says liquids are difficult to compress whereas gases can be compressed easily. Explain in terms of particles why it is difficult to compress liquids. That is because the spaces between molecules are very small and the intermolecular forces are very strong in comparison to gases. Question B says figure 3.1 shows a rectangular block floating in water. The density of the water is 1000 kilograms per meter cubed. So it's showing the rectangular block and there is a depth below the surface of the water 0.087 meters. The area of the base of the block is 0.014 meters squared. The base of the block has a depth of 0.087 meters below the surface of the water. Show that the pressure due to the water at the base of the block is approximately 850 pascal. So we use pressure equal rho gh, density times gravity acceleration times depth. So we have 1000 times 9.8 times 0.087. That gives an answer of 852.6, which is approximately 850 pascals. Part I says calculate the force F on the base of the block caused by the pressure given in BI. So we are going to use the approximated value this time. So we can use force equals pressure multiplied by area, and we multiply 850 by the area given in the question, 0.014. That gives an answer of 11.9 newtons, or we can approximate it to two significant figures as the question's numbers, so it's 12 newtons. Both are accepted. Part I says the force F is equal to the weight of the block. Calculate the mass of the block. So mass is equal to the weight divided by the gravity acceleration or the field strength. So we divide 11.9 by 9.8. That gives an answer of 1.214. So we can approximate that to 1.2 kilograms. Question 4 says a radio transmitter is a very tall, thin cylinder. It is prevented from falling over by wires which have one end fixed to the transmitter and the other end in the ground. The ends of the wires in the ground are a long distance from the transmitter. Figure 4.1 shows the transmitter and two of the wires. Question A says the center of gravity G is shown on figure 4.2, so this is the center of gravity here. Part I says state what is meant by center of gravity. It is a point in an object where the weight is assumed to act. Part I says explain why the radio transmitter without the wires is a very unstable structure. That's because it can topple over if it is tilted by a small angle. Question B says wire W is under tension and it exerts a force T on the transmitter. On figure 4.1, mark an arrow to show the force T exerted by the wire W on the transmitter. So this wire is holding the transmitter from falling that side, so the tension must be in this direction. This is the tension towards the ground, and the other wire would also be towards the ground, but it's not required in the question. Question B says the force T produces a moment on the transmitter about its base. So the base is the pivot. Describe how the moment produced by the tension T is calculated and indicate on figure 4.1 what is meant by any other terms in the description. So we can say that it is the force T times perpendicular distance D. So we already labeled T, we need to label the perpendicular distance D from the pivot. So going back to the diagram, this is the pivot and we need to draw a distance that is 90 degrees to the force or to the tension T. So this is what it means by perpendicular distance. It's perpendicular on the line of action of the force, which is T in this case, and 90 degrees to the pivot, which is the base of the transmitter in this case. Question C says the radio transmitter uses radio waves to transmit radio and television programs. State one other use of radio waves. We can say that it is used in radio frequency identification cards. or in Wi-Fi or Bluetooth signals. Question 5 says many methods of generating electrical power involve the use of water. Part A says describe one method of generating electrical power from energy stored in water, and we have 3 marks, so we have to choose one method that we can say a lot about. So it's in this case the hydroelectric power stations. So we start by saying in a hydroelectric power station, water falls from a great height to rotate a turbine, which rotates a generator. And then we talk about the energy conversions. The gravitational potential energy of the water is first converted to kinetic energy, then to electric energy. Question B says, for the method you chose in A, state one advantage and one disadvantage of generating electricity this way. So the advantages are it is renewable, or we can say it's a clean source of energy or non-polluting, and it is reliable. You can control the amount of energy produced. As for the disadvantages, we can say that there is a high initial cost, or it is dangerous to build, or that it causes flooding behind the dam. Question C says state 2 methods of generating electrical power for which the main source of energy is not the sun. So we only have 2 sources of energy that do not depend on the sun. That is nuclear fission reactors and geothermal power stations. All other sources of energy that produce electricity depend on the sun. Question 6 says a page of printed text is placed 18 centimeters from a converging lens of focal length 35 centimeters. So this distance is less than the focal length. Figure 6.1 is a scale diagram of the arrangement with each of the 2 principal focuses of the lens labeled F. Question A says a length of 1 centimeter on the scale diagram represents an actual length of 5 centimeters. Part I says by drawing on figure 6.1, locate the image of the page produced by the lens and label it I. So we need 2 rays at least from one end of the page or both ends of the page. And using figure 6.1, determine the actual distance of image I from the lens. So on the diagram, we choose one section or one end of the page from the object, and we draw 2 rays. The first ray is actually very easy. We start from the top of the page or the object, and we draw a straight line through the optical center of the lens. But since the object is between the focal point and the lens, we know already that this type of image will be virtual, so we need to extend the ray beyond the object from both sides. So we need to place the ruler so we can draw both sides, and we draw a long ray since we do not know where the intersection will be. The other ray, we start from the top of the object and we draw a line that is parallel to the principal axis, so a horizontal line, and we draw that line or that ray to the center of the lens. And from this point, we are supposed to go towards the focal point on the other side of the lens. So we move the ruler in this position, and we find the focal point. And we're also supposed to extend the drawing. So we place the ruler like this, and we move it until it intersects with the first ray. And now we draw the second ray, and we make the extensions of the rays dashed lines, so we can say that is not the real light. These are just extensions of the rays, and we draw the arrows to represent the direction of the rays. It is towards the lens from the object, but the intersection is at this point, and we're supposed to draw the image. So we have this height from one side of the page, so the same distance would be on the other side of the principal axis, and we're going to use the ruler to draw it from this point vertically down This is 3 centimeters approximately on my ruler, so we draw approximately 6 centimeters as the total length of the image. And now we count how many centimeters on the principal axis from the optical center to the image, or we can measure it using our ruler. This is approximately 7 centimeters. So this is the shape of the drawing. We drew two rays, one going through the optical center and then without deflection continues, but we had to extend backwards, and the other one was parallel to the principal axis, and from the center of the lens it bends towards the focal point, and then we extend it backwards, and the intersection of the extensions is the point where this part of the object creates an image. So the other part or the other side, since it has the same length, it created the same image from the other side of the principal axis. And then we measured the distance which was required in the question from the image to the center of the lens. That is approximately 7.1 centimeters. But it said in the question that every 1 centimeter on the diagram represents a length of 5 centimeters. So we multiply 7.1 times 5. That gives an answer of 35.5 centimeters. And by the way, not everyone draws the same exact diagram, so there might be a slight difference in the measured distance. Question B says, converging lenses can be used as magnifying glasses. State whether the image produced when a lens is used as a magnifying glass is real or virtual, and explain why. So it is virtual because it is made of extensions of light rays. The rays themselves do not intersect. We had to extend the rays backwards to find the intersection. Question C says, suggest how someone who is long-sighted may benefit from using a converging lens. So since the answer to that problem is a converging lens brings rays closer together or converges them with a greater angle, which means that they do not converge correctly at first. So they go backwards far behind the retina. That is a problem. So we start by saying long-sightedness focuses rays behind the retina, and a converging lens bends rays more, so they focus at the retina. This is how we fixed the problem. Question 7a says a plastic rod is uncharged. When the rod is rubbed with a woolen cloth, the rod becomes negatively charged. Explain in terms of particles why the rod becomes negatively charged. So first we mention which particles move. So we say electrons are transferred from the cloth to the rod. So the rod gains electrons and it becomes negatively charged. Question B says figure 7.1 shows a negatively charged metal sphere S. There is an electric field surrounding S. Part I says state what is meant by an electric field. It is a region where a charge experiences a force. Part I says on figure 7.1 draw the pattern of the electric field surrounding sphere S and indicate its direction. So an electric field around a spherical object is either radially outwards or radially inwards, but around a negatively charged object it is inwards, towards the object. So we draw lines that are pointing radial, and then we add the arrows which are pointing inwards towards the center of the sphere. Question C says figure 7.2 shows a small negative charge Z placed near to sphere S. Charge Z experiences a force due to the electric field surrounding S. On figure 7.2, draw an arrow to show the direction of this force on Z. So it is a negative charge and the sphere is negatively charged, so it's mainly repulsion, but it comes from the center of the sphere, so the arrow is pointing away from the sphere in this direction. You can use a ruler to point from the center of the sphere away from Z. Question 8 says a cylinder is made of modeling clay. The modeling clay is an electrical conductor. Figure 8.1 shows the cylinder. This is a cross section of the cylinder, and this is the length of the cylinder. The cylinder is connected into a circuit. Figure 8.2 shows that the circuit also includes a battery of electromotive force 9 volts and a resistor P. The resistance of P is 4 ohms, the current in P is 1.5 ampere, and since they are all connected in series, this is also the current in the battery and in the cylinder made of the modeling clay. The magnitude X of the charge that flows through P in 600 seconds. So we have the time and we have the current. We can use the equation charge is equal to IT, or current multiplied by time. So we multiply 1.5 times 600. That gives an answer of 900 coulombs. And part double I says the resistance of the cylinder of modeling clay. So to get the resistance of the cylinder, we need the voltage across the cylinder and the current in the cylinder. So the voltage in the cylinder is equal to the battery voltage minus the voltage across the resistance P. And we have the same current, which is 1.5. And we can get the voltage across P using V equals IR. Voltage is equal to the current multiplied by the resistance. So 9 minus the product of 1.5, the current, by 4 ohms, the resistance. And then we divide all that by 1.5. That gives an answer of 2.0 ohms. Question B says a cylinder is removed from the circuit and replaced with a new cylinder made of the same modeling clay. The new cylinder is twice the length and has half the cross-sectional area of the first cylinder. Calculate the time that it now takes for a charge of magnitude X, which was 900 coulombs, to flow through resistor P. First, we need to calculate the new resistance. So when length is multiplied by 2, the resistance is also multiplied by 2. They are directly proportional. But when the area is multiplied by half, the resistance is divided by half, that is multiplied by 2, since they are inversely proportional. So we take the first resistance, which is 2 ohms, and then we multiply it by 2, once for the length and once for the area. That gives a total resistance of 8 ohms. And now the circuit is a 4 ohm resistor connected to an 8 ohm resistor in series. So the total resistance of the circuit is actually 4 plus 8, that is 12 ohms. Now we can get the current. The total current in the circuit is equal to the total voltage, which was 9, divided by 12 ohms, the total resistance. We get a current of 0.75 amperes, and that is related to the time and charge. So now we can use time is equal to the charge over the current. So we divide 900 coulombs by the current 0.75. That gives an answer of 1200 seconds. So we could have just used this at first, but we would get the time incorrectly since we have a different resistance now and a different current. So we needed to get the current at first. But in order to get the current, we need the voltage and the resistance, and we did not have the resistance. We had to calculate the new resistance, but there was another resistor in series with the 8 ohm cylinder. There was also a 4 ohm resistor in series with it, so we had to calculate the total resistance and then divide voltage by resistance to get the current. Question 9 says many household smoke alarms contain a sample of the radioactive isotope americium-241. Americium-241 is the isotope of the element americium that has the nucleon number or mass number 241. State how the composition of a nucleus of americium-241 differs from that of a nucleus of 242. We can say that americium-242 has one more neutron. That causes a difference in one nucleon. Part double I says an atom of different element has a nucleon number of 241 also. State two differences between the composition of a nucleus of this atom and the nucleus of the americium-241. So since it is a different element, we have different proton number. But since the number of protons are different and we have the same nucleon number, which is the sum of neutrons and protons, we also have a different neutron number or different number of neutrons. Question B says americium-241 decays to an isotope of neptunium by alpha particle emission. Complete the equation for this decay. We are required to memorize the numbers for an alpha particle, which is 4 at the top and 2 at the bottom, nucleon number 4 and proton number 2. And now we can balance the numbers. At the bottom, we have 93 and 92 added together. That gives an answer of 95. So the proton number of americium is 95. And at the top, we can subtract 4 from 241. That gives an answer of 237. So 237 plus 4 gives 241 on the left side. Part I says one reason for using an isotope that emits alpha particles in a smoke detector is that alpha particles are more strongly ionizing than beta particles. Explain why alpha particles are more strongly ionizing than beta particles. They have greater charge and mass, which gives them more energy, by the way. So instead of mass, we can say energy. Part I says the isotope of neptunium produced by americium-241 is also radioactive. The decay of this isotope of neptunium produces an isotope of protactinium, which decays by beta emission. Beta particles are more penetrating than alpha particle. The half-life of neptunium is longer than 2 million years. Using this information, explain the advantage of this long half-life for the use and safe disposal of a household smoke alarm. So for a long half-life, this means it will have longer life. So we can use it for a long time. We do not have to replace the material in the detector. And slow decay causes slow or low activity. So low danger level. Since the amount of radiation per second is actually very small, so the number of ionizations per second are very small, which is not dangerous. Question 10 says the Milky Way is one of many billions of galaxies. Each galaxy contains many billions of stable stars. Question A says stable stars transfer energy into space by emitting electromagnetic radiation from their surfaces. Describe what happens in the core of a stable star to release energy that is eventually transferred into space. So the fuel for any star is fusion, but for a stable star, it is the fusion of hydrogen into helium. And we say that the loss in mass due to the reaction is converted to energy, or the lost mass is converted to energy. Question B says, on the Earth, light from a distant galaxy is observed and analyzed by astronomers. This information is used to determine the speed at which the galaxy is moving away from the Earth. Describe how the observed light is different from when it is emitted. So the observed light appears to have a longer wavelength or smaller frequency, and we can write between brackets red shifted. So whenever there is a red shift in light, this means that the object is moving away from us, or the source of light is moving away from the observer. And when it is blue shifted, that means that it is moving towards the observer. Part I says state the quantity that astronomers use to determine the speed at which the galaxy is moving away. The change in wavelength, since the change in wavelength is the indicator that an object is moving away or towards the observer. Question C says the Hubble constant h0 is equal to 2.2 times 10 to the power negative 8 per second. Calculate the distance from the Earth of a galaxy that is moving away at a speed of 1.3 times 10 to the power 7 meters per second. So we use Hubble's law that the speed is equal to the Hubble constant multiplied by the distance. So the distance is equal to the speed divided by the Hubble constant. And we have 1.3 times 10 to the power of 7 divided by 2.2 times 10 to the power of negative 18. That gives an answer of 5.90909 times 10 to the power of 24. So we can approximate that to two significant figures, since this is to two significant figures and this is 2. So we write it as 5.9 times 10 to the power of 24, and this is a distance, so the answer is in meters. Part double I says calculate an estimate for the age of the universe. Give your answer in years. So to calculate the age of the universe, we divide 1 by the Hubble constant. So that is 1 divided by 2.2 times 10 to the power of negative 18. That gives an answer of 4.5454 recurring times 10 to the power of 17 seconds. Now we need to divide that by 365 days, 24 hours, 60 minutes, and 60 seconds. That gives an answer of 1.44 times 10 to the power of 10 years, or approximately 14.4 billion years. And this was the end of the exam. I hope you enjoyed this video and found it useful, and I will see you in another video.